Next up, we have Eugene Cheah from Recursal and the key maintainer of RWKV. Let's give him a round of applause. Thank you.
Right. Hello, everyone. Yeah, I'm Eugene, the co-lead of the RWKV project and co-founder and CEO of Featherless AI, also previously known as Recursal AI. What is RWKV? RWKV is the first post-transformer AI architecture under the Linux Foundation. Our code is deployed into over 1 billion devices and is running on all your Windows laptop today. And a lot of you are wondering, what the heck does it do? Mostly translation tasks today. But more importantly, let's take a step back to what we are building. What does Mistral, OpenAI, and Llama have in common? They are built on the transformer architecture. And this works, but I think all of us have experienced the painful limits of the existing architecture where it tends to slow down as you talk with it. Like, as you talk with it with larger and larger context length, we have seen these models slow down. And the fundamental problem is these models scale quadratically in cost. It expands in memory and compute requirements for every token you process. Where in large models and long context lengths, these things start requiring terabytes of VRAM just to handle the large context length, larger than the model itself. Imagine it this way. If you as a human have a perfect snapshot of every second of your life, and you need to keep expanding your brain to keep track of everything, if this is how you work as a real-life human being, our brains will have exploded by the time we are 10 years old. And that doesn't make sense to me. So for me, this nature of the transformer architecture, where it has proven to work in AI, is what I feel is unnatural and an obstacle for my goal in bringing personal AGI, or sometimes I call it not so super intelligent for every one of you. So me and my team work on RWKV, a linear architecture that compresses its memories as the model runs, making it over 100x cheaper in inference cost over transformer. Quadratic curves are great when it's making you money, but it's horrible when you're paying for in terms of GPU inference cost. And this linear scaling of memories works in the same way as all of us humans, just like you and me. Do you remember the exact word-by-word replay that Quintin gave in the previous talk? No, but we all know that he was talking about scaling on infrastructure hardware. And that's how our brains work as we slowly process all this information. I can go deep into the architecture details of our system, of our models, but I don't think we actually have the time for that. And we actually do have multiple papers on this, which you can follow up respectively. But I think more importantly, right, is that while we have been scaling this in 7B, 14B, and more recently 32B, like we've been here before. Like the big AI critics constantly told us, recurrent architectures do not scale. Well, guess what? They also said MOE didn't scale before DeepSeek-R1 came out, and apparently it did. So today, I am proud to say that we are releasing Quirki 32B and 72B, both simultaneously, that was trained on the MI300. This just finished yesterday, actually. The world's strongest non-transformer, non-QKV attention-free model to date, proving that you do not need attention. Attention is not all you need. Because, I think what's more interesting is you look at the benchmarks here, right? When compared to existing transformer model, is that we can actually see that this attention alternative, right, improves against existing transformer models in certain key benchmarks. Well, likewise, it also didn't work out as well in some key benchmarks. It's all about trade-off. And because these models are open source, you do not need to trust me blindly. You can just take the model, run it, and do the eval on your own. Also, more interestingly, these models were not trained on tens of thousands of GPUs, or not even 1,000 GPUs. It was literally trained on 16 GPUs. A 72B model trained on 16 GPUs. And this was made possible because our team pioneered the technique where we can convert an existing transformer model into an alternative architecture on the chip. What we did is that we took the Qwen 72B and 32B, deleted the attention layer, and then added our RWKV attention layer. And we trained it at about 200 million tokens. That's it. That's why we only needed 16 GPUs. When we trained the attention layer, And we managed to achieve the evals that we showed previously. This has huge implication because it's much cheaper in inference, but more importantly, right, it means we actually all of us have misunderstood part of what makes AI models work. The majority of the AI's intelligence, right, is not in the attention layer. It's actually in the feed-forward network layer, as you can see the FFN at the top. Because that is the layer that we froze. We essentially have replaced everything else, and it still is able to score a high enough MMLU score or a high enough score in various tasks. So the way we should be approaching the problem is the attention mechanic is more to guide the model to stay focused. For those with ADHD, it's kind of like Adderall. And today, we are the only team who knows how to do this conversion process. And we are working on converting the R1. And yes, a paper is on its way. But for now, you all can have the model already. All of this model is available on Hugging Face and our inference platform, Featherless AI, where you can get unlimited requests for over 4,000 Hugging Face model, including a DeepSeek R1 at $25 a month. No token pricing, just unlimited requests for one user. I also mentioned that a good chunk of our traffic here is now running on the MI300s. But enough about the model drop and AMD. Like for me, what this release for us meant is actually timed very well on the pivotal moment that we have in AI. Because to me, right, we are seeing the change where open models is inevitable and will be fragmented. Essentially, you can't stop the Chinese teams from releasing more and more open models because they are doing so for various reasons beyond just profit. And we have seen the catch-up happening live over the years. And this is not just in the models release space. We literally see it on our platform. This is last month's inference chart of all the models that is running on our platform. And as you can see, the fragmentation in fine-tuning is so ridiculous, I can't even read at the bottom end corner. The funniest thing is, this chart, right, changes so often, right, it's going to be outdated by next month. And in addition to that, right, it's like, this is actually just a reflection of the literal millions of models that's being uploaded to Hugging Face. We are only representing a slice. Our goal is to actually eventually support them all. So yeah, if you want to find out more about the actual slides, right, there's an entire 30-minute video that breaks down what people use this model for. But I think for me, right, for this session, right, my other second hot take is that I don't think that the direction that we are heading, where bigger models, is the right direction. I actually strongly believe that personal AGI, right, triumphs over the superintelligence path that a lot of the big labs are doing. And that the path that we are taking is what makes sense for everyone. Because what we actually want, right, is not the smartest brain on earth. What we want is actually assistance to be able to help us in our day-to-day tasks, essentially. Because look at it this way. Today's best open models, like the DeepSeek R1 or the Grok models, can do orbital physics calculation from Earth to Mars. How many of us in this room can do this in under 5 minutes? I can't. I don't think most of you can. And yet, we can't use these models to be reliable enough to be a cashier at a college level, essentially. And that is the gap. Because, well, these models are undeniably smart, right? They are not reliable. And that's the issues that is actually plaguing the adoption of AI. We've seen this being expressed at the AI engineering conference by a lot of practitioners, that the main issue is actually about reliability, not capability. And what's incredible about the change with be it 𝘾𝙤𝙣𝙚 or R1, we have now reached the point where all the models are more than capable for pretty much any enterprise task. The question is, can we make it reliable? So, for example, and this is why we are excited about the direction that we are heading towards, because for us, right, that gap, right, well, it's being closed with prompting and fine-tuning, right? One of the things that we are researching into is actually memory tuning that is unique to the RWKV architecture. Because the RWKV architecture, as I shown after the conversion, actually has its own internal memory modules that can be tuned for specific tasks. And this is what we view is the direction to get us to 30 out of 30 reliability. We are not yet there, but with techniques that we have developed, we are able to close the gap. And that's where we feel that the research should be placed, not bigger models. Because because the models today are already good enough for entertainment use case. You want a model to insult you? Sure, you can just tune one accordingly. You want an entire AI town of NPCs? Sure, you can just tune that respectively. But to me, it's back to the fundamental that the models are already smarter than most of us. I'm not even sure I can get an MMLU of 70 across all domain. Sure, I can do that for physics and math, but my geography sucks. So the models today, even the 70B, are good enough. How do we make them more reliable? That is the question that we are chasing. And the best part is what we have shown with the conversion process. To achieve this, this research, you don't need a supercluster. Just 2 MI300 nodes per researcher is enough to iterate down this path. And that's essentially what we are building towards, where we are building towards a personal AGI in the sense that your models can have new experiences in the day, memory tuned in the night, all on a single unified infrastructure. So yeah, our slogan used to be the best open AI models made accessible for everyone, but we are essentially updating it to lightweight personalized AGI made accessible for everyone. Yeah, that's it.
Awesome. Thank you, Eugene.